Hi class, today we are going to learn about polymer. So this is the introduction of polymer. First, we have to know what is monomer. Monomer is a basic molecular unit that can combine with many others to form a polymer. And then when you want to combine to form a polymer, okay, we must know what is repeating unit. Polymer can be represented by their repeating unit in the long chain. So polymer actually is a macromolecule that is made up of many small repeating units from here, repeating unit, called monomer linked together by covalent bond. Okay, if we check the general formula, okay, it start from, by using compound A, it start from monomer, and then keep on repeating the compound A, and then it will form polymer with the N value at the end of the structure. Okay, and then the A actually is the repeating unit. So when the repeating unit join together, it will form polymer. So by using example of ethane, CH2 double bond CH2 as the monomer, and it join together, keep on repeating CH2, CH2, and then with the N is the polymer. Next is about the classification of polymer. There are two types of polymer. One is homopolymer, the other one is copolymer. Okay, homopolymer, homo means formed from only one type of monomer. For example, only formed from compound A. So it will form the polymer of compound A. And then we can use the example ethane again. So N number of ethane and then form a polymer of ethane. So we call it as polyethane. Okay, copolymer is a polymer formed from two or more different type of monomer. For example, here there are compound A and compound B. When it join together, right, it will form the polymer AB. So we can use the example of 1,1-dichloroethane. Okay, dichloroethane, and react with one chloro here, one chloroethane, and then form serine. Okay, this is the polymer of the combination of 1,1-dichloroethane and one chloroethane. Okay, later we are going to learn how to join them together. Okay, besides that, we also can classify the polymer with straight change polymer or cross-link polymer. Okay, straight change polymer is a linear polymer. So consists of monomer that are linked in straight or in long continuous change. Okay, so this is the example. So for linear polymer, right, it's recyclable because it is soft and can be reformed when heated. Okay, another one, this is folded linear polymer. So it folded in a random fashion. Okay, next is cross-link polymer. Cross-link polymer contain branches that connect linear polymer chain as shown below. So it's harder and rigid and more elastic. And then for this cross-link polymer cannot be remounted or removed. Next are the types of polymers. There are two types. One is natural polymers. Another one is synthetic polymers. Natural polymers is the polymers that synthesis in nature or occurring naturally. So for example, protein. Okay, this one is the most abundant organic molecule in animals such as enzyme, hormone, hemoglobin, and etc. And then the monomer to build up the protein is amino acid, which linked by peptide bond. Another example for natural polymer is carbohydrate. So the common example is starch. And then the monomer of carbohydrate is monosaccharide. The third example is natural rubber. So it will form the polymer we call it as 2-methyl-1,3-butadiene, or also known as isoprene. So actually, right, the isoprene is the monomer of natural polymer. So you have to take note, natural rubber is cis polyisoprene. The double bond in natural rubber are in cis configuration. So look at here, cis configuration. Okay, for synthetic polymer, right, okay, that are prepared in industrial from monomer that have gone through polymerization process. So it's a process that combine monomer to form polymer, classified based on their preparation method. We are going to learn this after this. Next, we are going to study about the preparation of synthetic polymer. So there are two types of synthetic polymer. The first one is addition polymerization. The second one is condensation polymerization. So what is the difference between these two types of polymerization? So the obvious one is the addition reaction in which unsaturated monomer are joined together by covalent bond. And then when it joined together, right, without eliminate any small molecule. But for condensation polymerization, it's a process that combines the monomer with eliminate of a small molecule, which is can be water, can be methanol, hydrogen chloride, or ammonia to form a polymer. And then for addition polymerization, always involve monomer which have the carbon-carbon double bond within the monomer, and peroxide is used as the initiator in addition polymerization. Okay, there are addition polymerization. Okay, there are four type of polymer which involve in addition polymerization. We are going to learn polyethylene, polyvinyl chloride, polystyrene, and Teflon. Okay, well, for condensation, right, there are two types. One is polyamide, and another one is polyester. Polyamide involve the functional group of carboxylic acid, means carboxyl, and with amine with 2 NH2 group. Okay, while for polyester involve carboxyl group and 2 hydroxyl group. Okay, so the example for polyamide is nylon 66 or nylon 6 or Kevlar. For polyester are terylene and Dacron. So we are going to look at the details for the example of addition polymerization and the condensation polymer. Next is about addition polymerization. There are 4 addition polymer that we are going to learn, which are polyethylene, polyvinyl chloride, polystyrene, and Teflon. So these are the monomer of each of the polymer. So first of all, right, we have to know addition polymerization involves combining monomer that have multiple bonds. For example, here carbon-carbon double bond, carbon-carbon double bond, same for the other two. And then without eliminate, so you check the product, there's no elimination of the small molecule. Okay, the monomer, right, actually can connected in the following method. So for example, okay, so eliminate, eliminate. So actually some of the reaction need hydrogen peroxide as the initiator for the reaction. Okay, and then it can form the free radical. Okay, so the free radical peroxide dissociate homolytic to produce peroxide radical in the change. So you check, right? Initial here is double bond and then become single bond after it initiate the reaction to form the homolytic peroxide radicals. Okay, yeah? So the same happened to here. Okay, and then form the single bond, single bond. So without the N, then it will be the repeating unit. Okay, these are the use of each of the polymer. So you have to know Teflon in making in non-sticking cooking coating on cookware. And then polystyrene is dissolvable cup and plate. And then polyvinyl is making water pipe and so on. Here, so these are the point or the notes that you need to know. How to write the monomer for the polymer, and then how to write the equation to represent the formation from monomer to become polymer, and then how to identify the repeating unit. Actually, it's simple because without the N, then this one will become the repeating unit. And then must know the function of each of the polymer. Next is the condensation polymerization. The first part involves polyamide. So there are 3 examples. The first one, nylon 66, is the monomer of 1,6-hexene diamine, so 1,6, and 1,6-hexene diode acid, okay, joined together from the polymer. Okay, maybe some of you might ask how to form the polymer. Right? So we are going to eliminate the OH from the carboxylic acid and one of the hydrogen. Okay, if I check, right, so this is one hydrogen and this is remain one hydrogen. So I'm going to eliminate the hydrogen from here when it join together, right? So it will eliminate the water. And then the N will join with the C double bond O. So this is the formation of nylon 66. So without the N, right, it will become the repeating unit of nylon 66. The use of nylon 66 is in making of fiber or carpet. Okay, second example, nylon 6 is formed from 6-aminohexanoic acid and 6-aminohexanoic acid. Okay, again we check. Okay, it will going to eliminate. Okay, Okay, because it didn't show the 6 amino acid. If by right, you have to show this plus this structure and then form this. Again, we will eliminate the H and then eliminate the OH and then form H2O. So this one is the repeating unit of nylon 6. Okay, class this one didn't show the repeating didn't show 2. If possible, right, you show the reaction between 6 amino hexano acids plus 6 amino hexano acid and then form this polymer. Function, fibers, ropes. Okay, the third example, Kevlar is a reaction between 1,4-diaminobenzene and terephthalate. Or another name is 1,4-benzene dicarboxylic acid. Okay, if you notice right here, I didn't use carboxylic acid. This is the derivative of carboxylic acid. Actually can accept. Okay, it will eliminate the H and Cl. So this is terephthalate, and then the elimination product is HCl, and then join the N and C, it will form the polymer. So actually this is the amide bond. Okay, the second part for condensation polymerization is polyester. There are two examples, terylene and dacron. Okay, terylene is formed from the monomer of 1,4-benzene dicarboxylic acid and 1,2-18-diol. Okay, it will eliminate OH from the carboxylic acid and hydrogen from the alcohol, and then C double bond OO, so ester will form. Okay, so this is join together the C double bond O join with the O over here and then form ester. So terylene is formed and then eliminate water. So the repeating unit is without the N. So this is polymer, the repeating unit without N. So this is there here is nothing. And then the function is making clothing fiber, tire cord, and plastic foam. Okay, for Dacron, the concept is still the same. Okay, we are going to eliminate the H from here, from 1,2-18-diol, and the OCH3, okay? Here and the OCH3, that's why this one will eliminate methanol. And then the C double bond O join with the O over here. So it forms as the C double bond O join with the O from the 1,2-18-diol and then from the ester. So this is how the condensation polymer form. Okay, eliminate, okay, the derivative of carboxylic acid. So meaning that this is OCH3 is eliminated and then join with the H from the alcohol. So for methanol. Okay, the function, plastic bottle. Thanks for watching. Please don't forget to click subscribe, like, and share. See you all on next video. Bye.